All right, good afternoon. Ooh, traffic intersection. We'll get that off. How's everyone doing? Pretty good. Cool. Wow, our numbers have dropped already. But that's okay, we're here. We have one camera turned on, thank you. Alright, finished PAA, excellent. Good deal. Yeah, so I've gotten PA submissions from some people. Some people have asked me to verify their downloads. Some people have uploaded successfully without verifying. So that's all good. So any issues or questions on what we've done so far, getting stuff submitted to Git and so on and so forth? Good to go. Yeah, pictures work. If you don't have a camera, that's fine. All right. Well, let's start off looking a little more at Git. So my anticipation is people are going to be doing more with Git this quarter, possibly than they did in 222. And if you're moving to a university next year, you're probably going to be doing a lot of Git, and you're going to be doing more complex things with this tool, and you're probably going to be working in teams. We're not going to get into the team aspect of this. We're not going to talk a lot about multiple branches and so on. But I wanted to look a little bit at how, even as just one person developing a project on our own, we can take advantage of this, and how we can respond to some of the things that go wrong sometimes. So let me go through some Git gotchas and some features. Oh yeah. All right, so here I am on my Linux laptop, right? And maybe I've been developing my code somewhere else, but I've just starting to use this laptop now more. I don't have all of my 223 work on here, but I would like to have it on here. Well, I've been pushing it over to Git, and it's in one repository called CSE223 submissions. So what I'm going to do is a Git clone. Git at gitlab.com, username, and then the name of the repository. And what that's going to do, it's going to create a subdirectory under my current directory. And that's going to be a copy of my Git repo. So if you come down here under CSE223 submissions, I've got 3 directories in here, right? Now we're not creating sub-repositories inside a master repository. We have one repository, CSE223 submissions. But inside there, we've typically had files. We've had make files, C files, a README file. We can have directories as well. And so each project we do is going to go into its own subdirectory. And these directories might have subdirectories inside them. And I might have directories here for, notes and things to try and stuff like that. But it's all sitting inside one directory tree whose root is, the top level of this repository. All right, so don't get too tripped up over this idea of submitting in a subdirectory, right? It's one repository. But if I have a new subdir, like let's make a PA3, and I'll flash back and do some C code. Right. And this this won't compile very well, but that's okay. You know, so I want to put this under git control, right? So what do we do? Git add star, git commit, and then git push origin master. Right? And I can do that from my subdirectory that I'm in. It's okay because I'm inside this directory tree whose root, one level up, is the root of the repository. All right. So for some of us, this is all we're ever going to do. We're going to work on one machine. We're just going to have one Git repository. We're going to keep pushing things over to GitLab. But it's useful sometimes to do this from more than one machine. For example, suppose for whatever reason, you know, you're somewhere, you don't have your laptop with you, but you want to work on your code. Well, you can hop onto the Linux server. And if you've already set this up once, you don't have to set it up again. So here's the Linux machine, right? And I've got, you know, all of my stuff under here. So I'll make a new directory. I'll spell it correctly. All right. I don't have any files in here. Well, what can I do? I can say git clone, git at gitlab.com, username, name of the repository. And now on my Unix machine, I've got a clone of my whole repository. And if I go into that directory, I've got all of my subdirectories, including this PA3 that I just created, which has the empty readme and the main.c that tries to call the haha, right? And I've also got, you know, my whole Git history. I've got my log messages from all of the commits that I've done, all those carefully crafted log messages that completely explain what's going on, and, you know, theoretically I can go back to old versions of my code and so on and so forth. So I've got, you know, my version on my local system. I've got a copy that I just made on the Linux server. And they're both cloned from, you know, the underlying source, which is the repo at gitlab.com. All right, so we can have multiple repositories. So when you have multiple repositories, it's really important to try to keep things in sync, which means the following. So let's say I'm on my Linux machine, right? I'm at that cafe without my laptop, and I'm down in my PA3 directory, and I decide to write a real readme, right? So this is the test of the haha command, because I'm hacking GCC. All right, git add, git commit, git push origin master. All right, so I've made a change to readme. Yeah, you can do a git commit -a to add all instead of putting in a star. Thank you. So I've made a change to readme, and I pushed that into my repository. The thing is, I get back home and I fire up my laptop, and I'm in here and I look at my readme, and it's still empty, right? And that's a good thing, right? Nothing should be changing files on my laptop based on what I do on the Linux server. The reason that this is still empty is because this is a local Git repository. And this change that I made to my local repository on the Linux machine, I pushed that over to GitLab, right? That's what the git push does. But I still have, you know, my own local copy on my laptop, so readme is empty. Now, if I want this to be in sync with, you know, the Linux server and GitLab, what do? I do a git pull. And it will tell me you're going to merge, you know, from gitlab.com into what you have locally. And now if I look at readme, it's got the readme that I pushed over from the Linux server. And this works great as long as you remember to keep things in sync. So I can edit main.c and change haha to a function, and let's call it a few more times. And I can git add, git commit, git push, origin master. And then if I decide I'm going to work on my Linux server again, before I do anything, do a git pull. And it tells me that it updated main.c. And now if I look at main.c, it's got my new changes in it. Okay. So the issue comes up when things get out of sync. And I'm going to do that right now, and this is something that you've probably encountered if you've done Git on more than one machine with the same repository. And I gave you a quick and dirty way to fix it in 222. We're going to look at the correct way to fix it here. Okay, so let's suppose I'm doing the following. Suppose I make a change to README. Alright, so here's the secret code, secret. Alright, so I've made changes to the README over here on the Linux server. And then, sometime later I'm back on my laptop, right? And my README is what it was before, and I want to make some changes to this. Alright, so I've got a new README here, and what do? I say git add, and I say git commit, and then I say git push, and this is where things start to go bad. Because when I do this, I get an error message from Git. I'm rejected, man. Alright, so what's happening? I changed my README over here on the Linux server and I pushed that to GitLab. And starting with the old README, I made a different set of changes and I tried to push that to GitLab. And things are conflicted now. Right? Now this would not have happened if before I made this change to README, I had pulled it from the repository. And so the kind of mantra to avoid this is pull before you push. Doesn't always work. But basically, if you're going to make changes to something in the repository, you want to start with the version that's actually in the repository. And my laptop was an out of sync version because I made changes from here and I didn't pull them in. Whatever the cause, now I've got a conflict, right? I have a version of README over here, right, with Typo Tuesday, and I've got a version over here with the secret code in it, right? And Git does not know how to take this and turn it into that, right? Because they didn't start from the same place. That is a dirty fix. But that works. Alright, we're not going to do that though. So we'll do a gentler approach. So what do we do? Okay, first thing we can do is shouldn't this push just overwrite the previous change? So if yeah, this is okay. So here's my laptop. Here's the Linux server, and here's the cloud. It's a blue cloud. All right. So I have some file A, and I push it here, and I pull it down, and now this has A. And now A gets changed to B, and that gets pushed, and I pull this down, and now I've got B. Everything is happy, right? Here's the problem. Suppose B changes to C, and I push that into GitLab. And over here, B changes into D, and I try to push that to GitLab. Well, if I was changing B into D, if I was changing C into D, right, GitLab knows what C looks like, it knows what D looks like, it can make those changes. The problem is C and D aren't coming from the same place, right? C is what's sitting in there. That was derived from B, but D is not a modification to C. D is a modification to B. So if I'm pushing something that modifies what's in GitLab already, it can apply those changes. But I'm pushing something that's a modification to something that's not what's currently in GitLab. Right, so this is when it starts talking about this fast forward option, right? And so it's confused. And the way to fix this is to take what's currently in GitLab, pull that down, modify that, push that in. Okay, and when we try to do that, things will start to get a little funny, but not too bad. So what am I going to do? I'm going to go on my machine where I'm trying to make the change. I'm going to say git pull, and I'm going to get some scary messages, right? Saying auto merge conflict, uppercase letters shouting at me, automatic merge failed. Okay, so let's take a look at my README now, and it's got some stuff added into it. The first two lines are the same. Git's totally happy with those. But here's what it's telling me, right? This is the stuff that I have in my version of README. This is the stuff that's in the version on GitLab, and it doesn't know how to put those together. Should it just replace this with that, or should it, put this in the beginning or the end of that, or interleave them, or pick and choose from each, and so on and so forth? So it tosses it to the programmer and says, you figure it out, right? Here's the file, here's the stuff that's okay, but here's the stuff that's in conflict. This is one version, this is the other. And you say, oh yeah, okay, yeah, so and-so added in the secret code, and I forgot to download that. So you call your friend up, you Slack them or whatever, and figure out what the version should look like, and say, oh yeah, we want to put the secret code in here, and then we'll go ahead and have my comments about Typo Tuesday, right? So you patch up this file however you want, and then you go ahead and add, commit, and push. So now it'll accept the push, that's all fine, and now if I'm on the Linux server and I want to start doing some work, first thing I'm going to do is I'm going to pull down, and I'll have that single unified README file, and then I can make changes, push it, and so on and so forth. The fix I give you for this in 222 is, just blow away the repository from GitLab, start a new repository, link it up with git remote add origin, and push everything over clean. And that works, but that's pretty heavy-handed, because you're basically wiping out your repository on GitLab and just starting over. And that's really not what you want to do when you're in a group project, right? But, this will come up in group work, and it's usually a 2 a.m. panic message from someone saying, all my changes have disappeared, or my code doesn't compile anymore because of that last push you made, or something like that, and it's just things getting out of sync. Try cherry pick if you want a clean top history. Interesting. Merges in the history when it's not necessary. Yeah. So this is one path through this stuff. We're doing this. Git is like huge, and I am not a Git power user. I can use it for my own stuff. I can use it to some degree with well-behaved groups of people. But when you're doing this, particularly in a group setting, it's really important that you understand up front what the rules are. And the rules are up to the people in the group, but you gotta know what those rules are, and you gotta make sure everybody understands them. Otherwise, this kind of stuff happens all the time. And with group work, usually you start getting into branches. Branches are like parallel universes. So you create an exact copy of the current repository, but you call it, issue 1. And this is where you're going to start working on some, bug fix or some feature development or something. And somebody else is working on issue 2, and somebody else is working on some other branch. And eventually the work that's being done in these parallel universes want to be brought together into the main branch, which is usually called the master branch. And that's got to be done just right. And you got to know, how do we push these things in? When do we push them in? Do we let people know when we're going to make changes? Can anybody push to this branch, or does one person control it, and so on and so forth? And that's just all, communication, and lots of fun waiting down the road in that area. The nice thing is that, Git remembers everything. So if somebody does something that blows away, all of your changes, well, the changes are still there. They've possibly been, occluded by some newer version or something like that. Yeah, so this is how team development usually works. So you'd have, a master branch, you'd have a release branch, which is the one that, parallels what's actually downloadable by the customer or client. You'd have development branches, you have issue branches, you have feature branches, and so on and so forth. And there's this hierarchy of development, and different things come in from different parts and feed different levels, ultimately leading to changes in the release branch, right? But you really don't want a developer who's making experimental changes pushing something to the release branch, right? That's when things happen, like, you get a call saying, Canvas isn't working. Well, because somebody, pushed something to the wrong branch, and now the whole state is down. Oh, that looks scary. Oh, nice. All right, so yeah, there's a good graph of branches that someone just shared in chat. That is cool to look at. So Git's a big wide world, and we touch on a pretty small set of it, but there's a lot more we can do with it. All right, so that's a little bit about Git. And most of this doesn't affect us. Like I say, most of us, we're doing single user development. We're working on one branch, and most of us are probably working on one machine. But if you start showing between laptops or the Linux server or something else, just try to keep things in sync. Pull before you push. And if that doesn't work, then you get to resolve conflicts. All right, so let's talk about objects. Let's start digging into Java proper. Yes. All right. So let's start by thinking about C. And so in C we have, structure statements. And what are structure statements for? Well, they let us group variables that logically belong together. So I'll do the same example I did this morning. Let's make a struct student. And a student has the following data. They have an ID number, which is an integer. They have a name, which is a car star. They have a schedule, which is an array of some other structure called a struct class, which lists, class name and meeting time and class number and all that kind of stuff. And this is just an array of these classes, right? We're not doing C, so don't worry about this. I'm just trying to show some examples, right? So that's maybe what a struct student is. And so we could, define a student, S1, And if we want to know S1's ID, we could say, you know, S1.ID equals something. And we could, you know, print S1.name, if print was a function, and so on and so forth. And if we want to add a new class to the student schedule, right, we could say add class S1, comma, you know, new class, where we have, you know, some new class we're adding to them, and so on and so forth, okay? So that's kind of the C way of doing things. And it's nice because, you know, if we didn't have structures, we could do parallel arrays. We could have an ID array, a name array, a schedule array, and we just keep them in sync. So ID 0 is the ID number of the student whose name is name bracket 0, whose schedule is schedule bracket 0. And ID bracket 10 is the ID of the student whose name is name bracket 10, and so on. That's a pain, right? So we can gather these pieces of data into this single structure, and now we have, you know, a variable of this type. And if this was an array, right, students, then students bracket 10 would have all of these fields. And so ID and name and schedule, we think of those as fields. This is the name of the structure. This is a variable of that type. And we're going to do something similar but different in Java. So in Java, we're going to make what's called a class. So a class called student, and it might have, you know, an integer ID, and, well, we don't have car stars. I'm not going to write that, but we could have, you know, a string called name, and so on. So similar idea, right? And we could create, you know, a variable of type student by just saying, you know, student S1. And if we wanted that student's ID, we could do S1.ID, and if we wanted their name, we could do S1.name, and so on. So far, this is kind of like, you know, an analog to what we do in C. This is defining a class named student instead of a structure. This is creating what we call an object. So S1 is an object of type student. An object is sometimes considered an instance of a student. So it's like a variable of that type. Here's where things get different, though. Right? In C, I have this function called add class. I give it the name of the student, I give it the name of the class I want to add to that student's schedule, and it does its thing, right? Well, just like certain types of data logically belong together, certain functions also logically belong together with certain types of data, right? I'm never going to call the add class function on an integer. I'm never going to try to add a floating point number to the schedule of an integer. It makes no sense, right? This is really supposed to be the you know, identification of some class, and this is supposed to be a student, and I'm supposed to be adding that to that student's schedule. I'm never going to use add class except when I'm referring to a student. And so I always pass this first argument as, you know, the name of the variable corresponding to a student, but I got to remember to do it, and I got to remember it's right in the beginning, and so on and so forth. And really, this should be part of this. So what's going to happen is when I define my class in Java, I can also write functions. I could also say there's a function called add class, and I can define that entire function in here, and that's all going to be part of this class called students. Right? So this is basically a structure that can include not just data but also code functions. Okay? That's the most kind of reductionist view of what a Java class is. It's like a structure in C, but it also includes functions. All right, and these functions are called methods. So method really just means function, but you know, terminology. And so if I have a structure, class student, and I make S1 an object of type class, yeah, I can say S1.id, and I can, you know, do some kind of print S1.name. But I could also say S1.addClass. And this refers to this field, which is now a method, this function inside the class student, because S1 is a student. And this is going to feel weird at first, perhaps, but eventually it's going to feel completely natural, and this is going to start to feel really awkward. Because think about it, you know, if we want the length of a string, we have a string length function. Well, what do you pass to string length? You pass a string. Do you ever pass it anything else? Do you pass it an integer? Do you pass it a dictionary of names? No, you always pass it a string, a char star. It's the only thing you do with string length. The only thing you do with math's square root function is you pass it a double precision floating point number. That's it. All right. So this is really taking the functions that kind of logically belong with this data and making it part of this structure. All right. So that's the wordy description of it. But let's play around with this. Let's look at the string class. Typically, classes are in their own files. So when you make a file.java and you compile it, you get a file.class file as a result. And that typically contains, you know, the class file. It could contain more than that, but they actually get broken off into different files. But yeah, for now, we can think of one class, one file. And we got people in chat talking about how it was strange to go from Java back to structures. Which is what I found too. All right, so in Java, right, strings are a built-in type in some sense. They're a class, which means we don't have pointers to characters. We don't have arrays of characters. We don't have null terminators. We have a genuine, legitimate type of variable called a string. Okay, but it's actually just a class. Here's the thing, everything in Java is a class, with a few exceptions that we call primitives. Everything in Java is a class. And so strings are no exception. So, so let's look at the Oracle documentation on strings, right? And this documentation is very standardized. You'll get used to looking at this. You'll eventually be writing documentation that looks like this. And we're not going to go through most of this today, but you know, there's links to other things up here. Here's the class that we're looking at, string. We'll talk about inheritance later, but string is actually a type of object. There's some wordy descriptions related to it. So this is like, you know, the top of the manual page in C. It's been around since Java version 1. There's different ways to make a string. Now we're going to make strings just by saying, you know, equals double quote. Just good old, you know, what you would typically expect. But what I'm interested in are the methods, okay, the functions associated with a string. And here's a function for telling us the character at some position. Remember, strings are not arrays. So if we have a string, we can't say, you know, string name bracket 5 to get the 5th character. But we have a function called character at. We have a function called concatenate to jam two strings together. We have a function called equals to tell us if two strings are equal. And guess what? We have a function called length, which tells us the length of a string. Yeah, there's a lot of functions. And there's classes that have a lot more functions than this in them, a lot more methods. So strings come with all kinds of things we can do to manipulate them. And for strings, strings are built in. If we use a bigger class like a linked list, we have to do what's called import that. And it's one statement, import, Java U the linked list or whatever. But this is part of the language, so it's built in. All right, and you can click through on these and get more detail. Well, there's not a lot of detail for length, but if I click through on it, it tells me it returns an integer, it takes no arguments, tells me the length of the string, the number of Unicode code units in the string, because this is no longer ASCII centric, right? All right, so let's write some code, and let's play with this. So I'm going to make a test file called test2, and it's going to be called test2 because I'm going to make a class called test2. So we haven't really talked about what all of this means, and we've barely talked about what any of this means, but we don't need to know it. My first 2 years of doing Java, I just had this in a file, and I just copied and pasted it every time, and I never worried about what it meant. I don't recommend that because I did a lot of things the hard way as a result. But we're basically making a class called test2, which is good because we're in a file called test2, and I'm making a main program. Oh, lucky. Yeah, I was old when I started learning Java. All right, so let's make a string. Make a string called S1. And I'm just going to give it a value like this. Now Java is very much like C, right? We got curly brackets all over the place. We've got semicolons at the end of statements. Everything is case sensitive. It's mostly indifferent to what you do with white space, so we can put spaces around the equals sign or in between lines and so on and so forth. So very familiar if you think back to C. So here's a string S1. Let's look at the value of that string. So our printf is system.out.println, and we'll just print S1. And there's the end of my main method, and there's the end of my class. So let's pull this out. Okay, so we compile this. javac test2.java. It does not correct typos for you. And then go ahead and run it. And not surprisingly, S1 says this is a string. All right, so that's pretty straightforward. Good time to mention concatenation. So we can use plus signs to concatenate strings. So I'm going to print out the value of S1 is angle bracket, and then I'm going to print out the string itself, and then I'm going to print out a closing angle bracket. Remember, I like putting delimiters at the beginning and end of strings to make sure I know if there's trailing spaces and things like that. So we're going to do that, we're going to compile it, we're going to run it, and the value of S1 is, this is a string. And its length is, well, I also want to print out the length of its string. It's this simple. S1.length. So what the heck is this, S1.length? Well, S1, if we think of it as a structure, if we said S1.id, right, that would be a field called ID. Might be an integer or something else. If we did S1.name, in C, that might be a character array, right? S1. What field are we looking for? Well, it's a field length parentheses parentheses. All right, so So it's kind of like C, but different. And where you want to stop thinking about how this compares to C and just think of it as Java, that's up to you. I'll stick with the C analogs for a little while, right? So S1 is a variable. This is, you know, the string itself, but this is resolving a field, which is actually a method, a function that's part of S1. And the length method says, tell me the length of the string. So I do have automatic syntax checking in the chat window, which is awesome. So compile that and run it. The value of S1 is this, and its length is 16. All right. So this is powerful. All right, and this is using a method. So let's see what other methods we have here. There was this character at method, right? It takes an integer, which we call index, and it returns a character. Index ranges from 0 to length minus 1, right? Because everything starts from 0 still. But if we want to know the fifth character, we don't say S1 bracket 5, we say S1 dot character at parentheses 5. So let's print out the contents of this string. So, you know, for loops look the same as they do in C. I'm declaring an integer inside here, so I'm just using integer I. I'm doing I is less than S1 dot length, so it's going from 0 to length minus 1, same as usual, I++. And let me put the word elements here in quotes, because they're not actually elements, right? But print all characters in there. I'm going to do something like this. Character, and I'm going to print out the value of I, so it'll say first time through character 0 is, and then it'll print out s1.char at 0, which my documentation says should give me the character at position 0. And character 1 is, and it'll show me the value of the character at position 1, and so on and so forth. Right, and there you go. Now you're looking at each character. And this is very different from C, right? Because usually if we wanted to do the length of a string, we would say length parentheses and we'd pass it the name of the string. Right? If we want the square root of a number, we call square root and we pass it the name of the thing that we want the square root of. But because the length function, the method, is part of the same class, we don't have to tell it we want the length of S1. If we say S1.length, it knows what string to take the length of. It's the string S1. So yeah, this begins to feel more natural the more you do it. It also can feel really costly the first few times that you work with this. It feels like you've got all these functions, and every time you make a new string, you've got a new function. Well, you kind of do, but you really don't. Let's make a second string. All right, so there's a second string. If I do this for S2, right? Now it's printing out the characters from string S2. Right? It's exactly the same code, except I'm doing S2 length and S2.character at. And this is just the way that how's that? Right, so the value of S1 is, and there's S1, and its length is, and there's the length. So yeah, this is a string, and that's a string. And we could also do this. So we could do it like that. So I'm concatenating. You concatenate strings with a plus sign. So here's a string, and I'm concatenating S1, and here's another string, and I'm concatenating S1.length. Now this is not a string, this is an integer, but there's some magic that we'll talk about in a little bit that lets me concatenate this as if it was a string. It's not exactly casting, it's the toString function, or toString method. But we can just pretend that plus sign just magically puts things together in a way that makes them look mostly reasonable. So we don't have to do, you know, %s and %d and all of that C stuff. All right. So takeaway from this that I want you to be thinking about is this idea of methods and the fact that this method is part of the class, right? Charadd is a method in the string class, and since S2 is a string, we can say S2.charadd. The difference is, since we're actually, you know, requesting a method, a function, rather than a piece of data, we put parentheses after the name of that method. And if we don't need any arguments, we still have parentheses there, like with length, to let the compiler know that this is, you know, a method, as opposed to just a field. Yeah, the plus sign basically yoinks the value of the thing you want. Exactly. And we'll see how that works later, and we'll write our own versions of what's called a toString method. All right, so that's our first, you know, kind of hands-on look at using a class, a string class in this case, and getting into some of the methods associated with it. And there's lots of methods for the string class. There's a substring method, which is really useful, which gives you a substring, right? So we could say something like this. Let's make a string S3, and I can say S3 equals S1 substring 1, 5. And I can print out what the value of that substring is. Let me get rid of this print statement. Right, so element from 1 to 5 is HIS, THIS. And substring will tell you, you know, if you dig down into it, it gives you everything from the beginning index to the ending index -1. So I actually asked it to give me the string from 1 up to but not including character 5. So T is character 0, HIS are characters 1, 2, 3, and the space is character 4, and that's where it ended. And this is one of these cases where you know, I would typically put delimiters around this. And then when you run it, you can see, oh yeah, there was also a space at the end of that. That's why I always throw delimiters on there. Yep, HIS space, exactly. And, you know, I can use temporary variables, but I can also do something like this. I can just say right here in the middle of this print statement, I want to print out S1 substring 1, 5. And that'll work perfectly well. And so this is where we really start getting into the idea of like code reuse and modular design, because we're going to write classes to encapsulate, you know, different behaviors that we're interested in, different types of data and methods for manipulating that data, and we're going to bundle those into classes, and we're going to be able to start using those in other classes, and it all starts to work together really, really nicely. All right, so that's kind of a first look at a legit class. So I'll post this code up along with this morning's code on the shared area on that you can get to through Canvas. So what I want to do tomorrow is I want to dig further into the string class. I want to start looking at some other things we can do with it, and in particular, I want to look at equality and revisit one of our horrible bugs from C programming days. And then we'll go ahead and take a look at PA1 and start talking about that. Cool. So come by office hours if you got questions. Otherwise, have a great afternoon. I will see you tomorrow.